Hello and welcome back to my YouTube channel. So in today's video, we're going to be doing something a bit different. What we have here is an architectural project. We have some walls and we have some ducts going through them. Now what we need to do is create a script in Dynamo. I'm going to be using Dynamo in this video to actually place some element right here to create the cutouts or the sleeves. Now you can obviously use windows right here or doors, like a door family, but I have opted to use a generic family like this one right here, which is a simple generic family. I've made it a communication device, and it can be used simply just by going to modify, cut, and you can cut it like this. Now the beauty of this, you can actually use it not only on walls but on floors as well, and on roofs. So how we're going to be doing this, using this Dynamo script right here. Now if you want to just get to the quick part, if you already know how to use Dynamo, you can obviously just copy this Dynamo script right here. It's nothing really that hard, and I'm going to be leaving a link in the description box. You can obviously just copy it. Let's run the script and see how it does. As you can see, it placed all these families right here. Okay, so without further ado, let's see how we can do this in Dynamo. So let's get it started. So the first thing I'm going to be doing is collecting all of the walls and the categories of. So the first thing I'm going to be doing is collecting the walls and collecting the ducts. Now you can obviously collide it with not just ducts, you can collide it with anything you want, but I'm going to be using ducts for this video. So we have categories nodes right here. We have collected the walls and the ducts. As you can see, the output is category, and we have a node called all element of category. What does it takes a category and gives you back all of the elements inside of this category. The same with the ducts right here. Now we're going to be using element.intersect element. Now this is from the biomorph package. You can download this package by going here and going to search for package and typing biomorph nodes and downloading the one with the Dynamo version you have. Now after we have intersected the elements, we're going to be getting the geometry of the element. So Dynamo works in a way that the element itself is a Revit element. When we have a geometry node, it converts this element into its 3D shape. Okay, now we have converted all of the elements that we have. I'm using the shortcut Control B to cycle through this preview right here and this 3D view. Now when you convert this to an element geometry, as you can see, we have the geometry shown right here in the background. And now we're going to be using a node called geometry intersect. Now if you hover your mouse right here, you can see what it gives back. So as you can see, it gives us a solid. A solid is a type of geometry, and we use this intersect to get actually another type of geometry. Now as you can see, if you select this node, it highlights the geometry in the preview. Now let's right click and turn off preview. Let's do the same right here, turn off preview. As you can see, we have left with these boxes right here. These boxes are actually the intersection of these two geometries. So this is what node does. Now I'm going to be using something called geometry explode. It takes this geometry right here, these solids, and explodes them into their surfaces. As you can see, a box is made out of 6 surfaces. Now once we do this, we're going to be having multiple lists inside of a list, so it's nested lists. As you can see, every box is turned into its equivalent surfaces, yes. As you can see, we have them. We have 6 surfaces. Now Dynamo is just like any programming language. It starts the indexing at 0, so we have 0, 1, 2, 3, 4, and 5. Now we're going to be getting this surface right here. Now we need a node to get this surface. We need to get this surface and this one, and this one. So all of the surfaces at the index 0, sorry. I'm going to be hiding this. Let's use a node called list get item at index. Now it takes a list and let's give it an index. So I'm going to be using 0 just like this. Okay, let's see what we have. We have an empty list. Awesome. Now, because we have all of these surfaces as nested inside of a list, inside of a list, inside of a list, inside of a list, sometimes the Dynamo nodes doesn't work correctly. So what we need to do is specify at which level we need this to work. Now, as you can see, this is the level 1. Now I don't need to use it here, because if I use it at this level, I'm going to be getting this surface right here. I'm going to be using it at level 2. Let's use levels. Now, when we choose level 2, as you can see, we have now 4 surfaces. We have taken this surface right here, this one, and this one. So let me remove this. Now I have 4 surfaces at index 0. So I need to get the first surface of each box. And I want to get the center point of this surface. So surface point at parameter is the node we're going to be using. So surface point at parameter, we feed it a surface. So we feed it a list of 4 surfaces, and it should give us 4 points. Okay, so what is the U and V parameters? Each surface is divided into UV, just like X and Y, but because not always the surfaces are aligned with the coordination system, so we use U and V. Now, if you use 3D Max, you obviously know what I'm talking about. So, and the U and V value are ranging from 0 to 1. So 0 is at one end and 1 is at the other. So I need the center. So obviously, I should feed it on 0.5. So I'm going to be feeding U and V 0.5. Now, if I click Ctrl B, I can see this point right here. This is it. I can obviously remove the preview from this, remove this preview, and remove this preview, and I'm left with these points right here. Now we're gonna be going back a little bit. So what we have done right here is actually intersected these elements, this geometry, and got the intersection center of some of these points. Now what we need to do is actually place these families on the surfaces right here, on the surfaces of the walls. So what we're going to do in a nutshell is collect all of the surfaces of the walls and figuring out whether the surface of the intersections resides inside of the wall face. Then we have the wall face that we're going to be placing the family, because this family is actually face based. So but we cannot feed it the face of the intersection, because the intersection is the Dynamo geometry. It doesn't represent anything in Revit. What we need to actually supply it with, we need to supply it with the face of the wall to actually place our family. So let's go back to Dynamo. Now what we're going to do is collecting the faces of the wall. So we do that with an element.faces node. Okay, as you can see, we have all of the faces loaded in Dynamo. I'm going to be using flatten. Now, as you can see, we have 3 levels of lists in our element.faces node, but I want to flatten it all out. So I want to have one list, all of the elements. So I'm going to be feeding this. And if I hover my mouse over the spin icon, you can see all of the surfaces right here. Let's continue. And the method we're going to be using to figure out if the point of the intersection box lies within our surface is something called bounding box by geometry. So bounding box by geometry takes the geometry, the surface, and creates a bounding box around it. And we have a node called bounding box contains. So this is the bounding box that we have. And the point we're going to be using right here is this point right here. So it should give us a list of all of the surfaces whether they have this point or not. And it gives us in a way called true or false values. We have only 4 values right here due to the way that lacing is set up. Now, a little bit about lacing. So let's imagine you have 2 lists. List number 1 contains 5 elements of points, and the second list contains 7 elements of points as well. Now you want to create a line between the first list and the second list. So the data matching, or lacing as it's referred to in Dynamo, you have multiple ways. Shortest is when points from index 0 are matched with points from index 0. Points from index 1 are matched with the point from index 1, and so on. And if you have 2 lists with different indexes or different amount, it stops at the shortest end. The longest end, as you can see, it matches the same way as the shortest, except when you get to the end, you have the point at level at index 4 is matched with the point at index 4, 5, and 6. Cross product is when you have the point from index 1 is matched with all of the points from all of the indexes, and the same for index 1, index 2, index 3, index 4. So what does this mean for our project right here? Well, it means that we're going to be using cross product because we want to see all of these points are matched with all of the surfaces right here. So go to lacing and cross product. Okay, as you can see, we should have 30 lists, and it shows us if the list has any of the, as you can see, the list 25 is matched with the third or the fourth point from the surface point at perimeter. And we're going to be using a node called list.contains. What does it? This node just checks the list and see if there is a true value in one of its indices and returns true. So here it will return true because we have a true value, and here it would return false because all of our indices, all of the elements are false. So list.contains, and let's see if contains true. So I just double clicked, we create a code block, and I just typed in true. Oh, not like this. TRU, as you can see, I just clicked the type as the tab button. Okay, item true. Let's see what we have right here. True. Okay, what it's doing is actually scanning all of the elements right here, like it's a 1 list, but I wanted to change the level because I want to check on this level right here, not the level 1, not the level 3, but the level 2. So I'm just going to be using levels, level 2, and now we have 30 lists, and it's a good thing to check. So let's see, in this index 18, okay, index 18, we have a true value, so it returns true. 17, all false, it returns false. So it's working. Let's continue from here. I'm just going to be removing this right here. Now we're going to be using list filter by bool mask. Okay, this is going to be our mask. So list filter by bool mask works simply by feeding a list and feeding a mask or values of true and false, and it shows us which, and it just creates like a mask in Photoshop and gives us only the in we have the elements that are true, and out are the elements which are false. So we go right here, list flatten. This is the list we want because I want to get the surfaces. I don't want to get the bounding box. So create this bounding box. This bounding box contains, and the list contains, just to get which of these surfaces actually contains the points right here. And now we have them. These are the ones. We can continue. How we're going to be placing family. We have family instance by face. We have 2. We have one right here. I'm going to be using this one right here. As you can see, you already have a preview of all of the inputs you're going to be needing. We have a family type, and we have a face, location, and reference direction. Well, we already know the locations. The location are these points right here. Okay. Now for the reference direction or the normal. So I'm going to be using surface normal at point. So I'm going to be feeding it the surface like here, and the point. I'm gonna be rotating this by -90 on the z-axis. As for the face, this is the one right here. Okay, now for the family type, I'm going to be using family type by name, and the name I'm going to be choosing AB. You need to actually specify as a string. Okay. Oh, sorry. It's in Russian. Okay, now it found it. And then family type. Now, what I like to do before I connect this final node, I just want to make it a manual. Nothing is going to happen. As you can see, function doesn't show anything. If I click run, now I have a list of the IDs of all of these elements. Let's see them right here. As you can see, it created all of these families and placed them at the point where we have the intersection. Now you can obviously modify this script a lot. You can take these elements and give them the width and height, depth parameters. So you can give them the depth parameter of the wall. You can give them the width and the height of the ducts. But I'm not going to be doing this. This is only a demonstration. And you can obviously modify it to work on not just walls, but on floors and ceilings and roofs. I hope you enjoyed this video. Now, if you have any suggestions, you can type them in the comments. And if you like this video and want to see more, hit the like and subscribe button.